Good morning, happy Monday. This is Miss Drake doing this video, and I was just showing you my little rigged up setup. I've got my way of trying to video these notes for you guys. I'm sitting here at my kitchen table. I've got my whole little system going on. Hope that y'all are doing well and ready to do this first day. So this is the worksheet we're starting with, Simplifying Radicals, Day 1. It should be in one of your packets, so you can pause and go get your worksheet or whatever you need to do to get yourself started. And then come back and join us. Also, I put at the top of the page that we're doing notes as all of the odd numbers, and then you'll go back and practice and do the even numbers. I'll do 2 separate videos. We'll do the notes and kind of take a little more time to teach it, practice. You'll do those on your own, and then if you need help with any of them, you can go back and either check the key or you can watch the homework or practice video. Also, I've already filled in the top box, so pause and do that for yourself. We've practiced these, we quizzed you on these, and you can also use your calculator to find these. But we want you to be thinking, as we simplify these radicals, we want you to be thinking in perfect squares, all right? So that this, 2 squared is 4, 3 squared is 9. We want you to be thinking in perfect squares so you can simplify them to the best of your ability. All right, so we're gonna start with number 1. I'll do the odd ones. I'll start out kind of slow, but then move forward. So remember that if you need to slow down and pause, you can. All right, so when I look at this, my directions say simplify the following radical expressions. When I simplify, that means I don't want any perfect squares left under the radical. So no perfect squares left under the radical. So you've got to make sure your goal is to get everything cleared out. So right here, I'm going to look at my number. I've got negative 10 square root of 4. Negative 10 is a whole number in front. I'm going to look at the number under the radical and ask myself if it's a perfect square. Well, I want you to memorize those. You've got your sheet. You can also use your calculator and see that, yeah, 4 is a perfect square. The square root of 4 is 2. So I can rewrite this with my number in the front, multiplied times the square root of 4, which now we know is 2. If I multiply those together, my answer is negative 20. All right, number 3. So on number 3, we're going to just say 8. We're going to break this into perfect squares. If I think about the factors of 8, I know that 4 is a factor of 8 and 4 is a perfect square. So I can rewrite this and say that this is the square root of 4 times the square root of 2. Because those 4 times 2 give me 8. That is a fact. Those are factors, and this is a perfect square factor. So this number, I'm going to use this. I'm going to take the square root of 4, which now I know is 2, and then I'm going to just rewrite the square root of 2 because I know that this cannot come out of the radical. I look under the radical. 2 is not a perfect square, so this is in simplified form, and that is my answer. Number 5. So now I've got the 2 on the outside and then 81 on the inside. I ask myself, is 81 a perfect square? Actually, it is. The square root of 81, you can see on your chart, is 9. So even if you can try that in your calculator, do the square root of 81. You see it is 9. So I'm going to rewrite that as 2 times 9 because we know the square root of 81 is 9. And I get 18 as my answer because I multiplied the 9 times the 2 that was already in front. Number 7, square root of 45. Is 45 a perfect square? No, it's not. When you put that in your calculator, you get a decimal. So that lets you know it's not a perfect square. So I'm going to think about perfect square factors of 45. And you can use your chart as a guide. I know I wouldn't start at 49, so I'd start looking down through here and I would do 45 divided by 36. That's not going to go into it evenly. Divide by 25, that doesn't work. Divide by 16, that doesn't work. But if I divide 45 by 9, I find that 9 times 5 will give me 45. So I can break this into the square root of 9. I usually write my perfect square first. Square root of 9 times the square root of 5. All right, well, I'm going to take the square root of 9 because I know that I can. So now I have 3 times the square root of 5. So it's just 3 square root of 5, and that is my final answer. All right, number 9. So I'm looking at 6. Is 6 a perfect square? No, it's not. I'd get a decimal if I put it in my calculator and it's not on my list. So what do? There's not anything in there. So you know what my answer is? I just leave it the same. That is simplified because there are no perfect squares or perfect square factors underneath the radical. So that's it. All right, that's number 9. Now let's go to number 11. Ask yourself the same question. Is 75 a perfect square? It is not. So I start thinking about perfect square factors. You can look at your chart. You can start at 64 if you want to, but you start looking for perfect squares that might be a factor. And I see 25. I know that 25 times 3 is going to give me 75. So I'm going to do 25, square root of 25 times the square root of 3, and that's going to give me 5 square root of 3. Once I take the square root of 25 is 5, and then I have to leave that alone because that's not a perfect square. So if it's not a perfect square underneath the radical, you leave it there. It's done, okay? If you cannot find any factors or anything like that underneath it. All right, 6 times the square root of 400. So that's a much bigger number, but you can look and you can say, oh wait, 400, that is a perfect square. The perfect square of 400 is 20. So I'm gonna say 6 on the outside times, I know the square root of 400 is 20. So 6 times 20 is gonna give me 120. Right now, I'm really dying to be able to wish I could say, Beyonce, what'd you get for number 15? Or what do I do next? Crystal or anybody, Luke, Zach, I mean, all of you guys, you know, Lorna, everybody, we're missing y'all, Caden, Jacora, Sam and Luke and Davion and Ray Ray. I'm just missing you so much. And I wish I could see your faces and Lane, and I'm just seeing how this is computing. If you'll have questions, I have a feeling you guys are doing great with this though. So the square root of 180 is, if I try to take the square root of 180, it's not a perfect square. All right, so since that's not a perfect square, I ask myself, are there perfect square factors inside of 180? So in my calculator, I could take 180 and start dividing it by some of these numbers. Like I could see, like, can I divide it by, you want to be reasonable, use your judgment, but you can start trying some of these numbers and see, and you'll find out that you can divide 180 by 36, and it goes 36 times 5 gives you 180. So I'm going to rewrite this as 3, and then I can do the square root of 36 times the square root of 5. Like that. That's one way of looking at it. I know that the 3 is just my whole number in front. That's my perfect square, and then I cannot take this out from under the radical because it's not a perfect square and it doesn't have perfect square factors. So that's going to be 3 times 6 times the square root of 5, which is going to give me 18 times the square root of 5. And that is your answer because it is simplified at that point. Okay, then we're going to do 17. Oh, I have a variable now. So we're going to have to review how to handle variables and take the square root of a variable. So I'll slow down for just a minute here. I want to rewrite this for just a second as the square root of 7y, because that's really what that says. Okay, so that's like I have 7y under there. And I'm looking for perfect squares, which you know means 2 of them multiplied together. So I'm going to look for groups of 2. The way you simplify it is the number of groups of 2 you have is what you take out. So I know I have 1, 2, 3 groups of 2. So I'm going to, in front of my radical, I'm going to write y to the 3rd because I could take out 3 y's as perfect squares. But I have this y right here left underneath the radical. So it's going to be y cubed, and then you leave that y underneath. A couple of things that I want to start showing you and reminding you. If this exponent right here is odd, which it is because it's a 7, Whenever that is odd, you will always have one of those variables left in the radical, because it doesn't divide evenly by 2. So you'll always have one left over. And you'll see in a second that if that number is even, it always will divide evenly by 2. So you'll be able to pull out an even number and not have to leave any underneath the radical. All right. Another way that we look at this same problem, I'm going to do it in a different color just so you can see it's a different option of way to look at it. You can say we write y to the power over root. So I'm going to say y to the power, which is 7. This is your power. And then your root is this understood 2 right here. And it's not a negative. So let me see if I can erase that. My fancy pens. So that is, the root is 2. So if I put power over root, that means I'm going to put y to the 7 divided by 2. So it's going to give us the same thing, but we're going to do a division problem right here. You've got to think 2 goes into 7 3 times, but you have a remainder of 1. So that means I'm going to say I can pull out 3 y's because it goes into 7. 2 goes into 7 3 times. And then I'm going to have to leave that remaining y, the remainder I have, underneath the radical. And it's a different way of looking at it, but that's how you get your answer. All right, so now number 19, we have 2 variables. Doesn't matter, we're just going to do the same thing. We'll just do it for both. So we've got, I'm going to rewrite this. And you can do it however you choose, but I'm going to start doing this way. This is x to the 4 divided by 2 and y to the 8 divided by 2. So I notice that these are both even, right? So that means I'm not going to have anything left underneath the radical because there are no remainders when I divide those. So when I divide 4 by 2, 2 goes into 4 2 times with nothing left over. 2 goes into 8 4 times with nothing left over. So that is my answer. All right, now I'm going to flip it over and we're going to start working on the back, some of the odds. All right, I'll pick up the pace just a little bit and see, remember to pause it and, email us, ask questions, do whatever to make this easier for you. All right, so x to the 14th, y to the 9, z. Remember, this is an understood 1 right here is the power, so don't let that confuse you. All right, as I'm looking at this, I know that 14 is an even number. So when I divide 14 by 2, I'll be able to pull out 7 x's and leave none on the inside because that means there are no remainders after I divide. Then when I do 9 divided by 2, 9 is an odd number. So that means I am going to have to leave, when I divide that, I will be leaving a y in there. And then I've got z to the 1 over 2. Well, that's a whole different ballgame we're going to need to talk about. Because can you divide 2 into 1 at all? You can't. You only have one z, so you can't take out 2 of them. So that z doesn't have any perfect square factors, and it's going to have to stay under the radical just like it is. So what I'm going to do, this becomes x to the 7th. This becomes y to the 2 goes into 9. That goes 4 times with a remainder of 1. And then I'm going to have to leave that z to the 1 underneath the radical. That is my final answer. All right, moving along. Number 23, I've got x to the 10. That is an even. X to the 10 is 10 is an even power. So I'm going to do 10 divided by 2 is 5, and my answer is just x to the 5th. Bam, done. 25. I have one odd and one even. So I know I'm going to take some x's out and leave one of them in, and then I'll take out both of my y's. So this is going to be x to the 5 over 2 and y to the 2 over 2. So remember, I'm doing the power divided by the root, and that's an understood 2 right there. We just don't write it. Y'all know that. It's called a square root because that's an understood 2. So 5 divided by 2. 2 goes into 5 2 times. and I have a remaining x underneath because I have a remainder. 2 goes into 2 one time with no remainder. So I just pull out that y and I have no remainders of the y. 27, this is an odd number. So, 25 is an odd number. So I know I'm going to have a remaining x in there. But let's see how many times that goes into it when I divide. 2 goes into 25 12 times. And then you're going to have that remainder underneath. That's your final answer there. Okay, 29. These are both even, so I shouldn't have any remainders. So I have 6 divided by 2 is x to the third, y to the second. 31, that's even, so it should work out just fine. So power divided by root, 16 divided by 2, that's just x to the 8. 33, you've got x to the 9th, y to the 1. All right, remember, we're going to have to leave an x on the inside once I divide, but that's going to be 9 over 2 and y to the 1 over 2. So 9 divided by 2, that's going to take out 4 and leave 1 on the inside. So I'm going to take out 4 x's and leave an x on the inside. And then I realize that since my power is smaller or lower than my root, I cannot divide at all. There are no perfect squares there. So that's when I leave that y on the inside. All right, x to the 4th square root of xy. 35, x to the 21. Hopefully you guys are getting the hang of this now. All right, power over root, and then I divide. 2 goes into 21 10 times, and I have a remainder of 1x left on the inside, like that. Okay, almost there. 37. Oh, now I've got going back to numbers. All right, 48 is not a perfect square, but when I start dividing and trying to find perfect square factors, I find that I'm going to have the square root of 16 times the square root of 3. All right, so when I do that, I'm going to take the square root of 16. So I have my whole number in front. I have the square root of 16, which is 4. So that's where that comes from. Then I cannot take the square root of 3. There are no perfect square factors in there, so it stays under the radical. 7 times 4 is 28, and I have 28 square root of 3 as my answer. All right, let me do that just one other different way. Let's say you didn't come up with the 16. Let's say you thought of doing it as a 4 in there. 4 goes into 48 12 times. So let's say we start out with this. And you broke this into 4, square root of 4 times the square root of 12. I want you to see the difference. So this is going to be, I know I can take the square root of 4, so it's going to be 7 times 2 times the square root of 12. The difference is that 12 also still has a perfect square factor in it. So I can still simplify that into square root of 4 times the square root of 3. All right, so it just makes the problem a little bit longer, but you can still do it. So at this point, I have 7. I'm bringing these down. 7 times 2. Then I've got to take the square root of 4 and get 2, then multiply by the square root of 3. 7 times 2 is 14, times 2 is 28, square root of 3. So we got to the same answer, but you've always got to look at your radical at the end. Make sure there is not a perfect square left under the radical or a perfect square factor within that number. You have to get it to its simplest form. Okay, one more for notes. We've got 9 square root of 72. So I'm going to think about 72 and I'm going to find perfect square factors. Again, if I find the largest perfect square factor, it shortens the problem for me. So I know this is going to be 9 times the square root of 36 times the square root of 2. So I just brought my 9 down, bring it down again. Square root of 36 is 6, and square root of 2 does not have a perfect square inside it. So 9 times 6 is 54. Square root of 2 is my final answer. And I know that is final because 2 does not have a perfect, it's not a perfect square, and it does not have a perfect square factor. All right. If you listen to this whole video, I want you to turn your paper back over to the front, and I just want you beside the notes, right out to the left-hand side of the notes where I wrote this, I want you just to write me a big smiley face. And that shows me when you submit this, I'll know that you watched the whole thing, and I'll give you an extra point, okay? Because I know you watched the whole video. All right. Stay tuned for a homework video. And email me with questions. Bye.